Hey guys, so this is our video for Are You Learning Volume Day 2. The only thing that's changing today versus last week is that we're looking at different types of three-dimensional figures. So last week we looked at prisms, cylinders, and spheres. This week we're going to be focusing on pyramids and cones. So what's changing a little bit is what the formula is. Other than that, the idea is the same. Volume is still the space inside of a three-dimensional figure. And remember, it's always in units cubed. So you always want to put that little 3 as an exponent on your unit. And then we're going to look at what the formula is. Luckily for us, the formula for a cone and a pyramid is actually the same blueprint. So remember, we have this blueprint where we have this big B. That means area of the base, right? So it's the area of the base of our pyramid or cone. And then this little h is the height of the entire figure. So not just the base, it's the height of either the cone or the pyramid. What's nice is that cones always have a circle for the base. So no matter what in a cone, a circle is the base. That helps us out because it makes it a little bit easier to decide what is the area formula of our base. With pyramids, there are different bases that you can have. The only ones that we're going to be focusing on in this class are triangles, squares, and rectangles. So nothing too wild and crazy. We don't have to look at trapezoids and things like that. Okay, so the formula is 1/3 times the area of the base times the height. So that's 1/3 big B times H. So if you remember when we were looking at prisms, cylinders, and spheres, we had 2 different formulas to worry about because prisms and cylinders were the same and spheres were different. This time, we're lucky we just have the 1/3 big B times H. The biggest obstacle that we have is finding the area of the base. So I'm going to go and I'm just going to show you guys some examples. This really shouldn't take too long for me to get through, and then you're going to do a homework assignment very similar to what you did last week. Okay, so at the top, you'll see on these notes, we have some steps listed. They're almost identical to what we had last week. They're just a little bit more specific and written out for you since this is an e-learning assignment and we're not going through it together in class. Although if you do have questions, you can ask me when we're in class together. So the first thing you're going to do is ask yourself, what am I dealing with? Am I looking at a cone or am I looking at a pyramid? Remember a cone, I guess what's the easiest to think about is maybe like a birthday hat like you would have when you were younger at birthday parties. A lot of people think about the cones that you put around your pets' heads if they're like scratching too much or they have an infection. So cones are the ones that have the circular base. So if it looks like it has a circular base, then we know it's a cone. So we're going to go to this first set of steps. Like we said, the base of a cone is always a circle, and then we're going to find the area of the base. So then what we have to do is look at, well, what's the area of a circle? That formula is pi r squared. That's never changing. That's always the area of a circle. So once you realize you're dealing with a cone, you're going to find the area of the circle, and to do that, you have to know the radius. So you're going to identify r. And what we need to remember is that r is the distance to the center of the circle. So if I'm looking at a circle, so say this is the base of my cone, r would be this distance. If you are given this distance, you need to cut it in half because you only want the distance from the center to the edge of the circle. Once you figure out what r is, all you're going to do is plug that into pi r squared and get your area of the base. When you do that, you have big B. So step 1 is to find big B. Step 2, we need to identify the height of the cone. So when you're looking at the cone, you're going to have something like this as your picture, and you should have something like that that shows you what the height is. So you're just worried about the height of the entire cone. Okay, so that's going to give you H. So we got step 1 giving us big B, step 2 gives us H, and then that's all we need. Now all we have to do is go and plug those 2 numbers into our volume formula. So into our 1/3 big B times h. Your calculator does that for you, and then you're done. Now, if the figure is a pyramid, the only thing that's a little bit more difficult is we have to determine what is the shape of the base. Is it a triangle? Is it a square? Or is it a rectangle? So then we're finding the area just like we did with the cone. We have to find the area of the base. If it's a triangle, you need to remember that the area formula is 1/2 little b little h. That's just 1/2 base height. So if you're looking at a triangle and I give you a height and there's a number on the bottom, that's their base and this is your height. So you would just do 1/2 base height and that gives you the area of your base. So if it's a triangle, at that point you're done. If it's a square or a rectangle, it's even easier. You just don't have to worry about the 1/2. You're just gonna multiply the base and the height. Next, same idea. We're gonna find our height of the pyramid. And you can kind of see in this example down here, it's gonna be that line that's outlined in red. So it'll be obvious which one is the height, which is nice. Then we're gonna plug in B and H to our formula and we're done. So again, the formula itself isn't changing between cones and pyramids. What's changing is the area of the base. So that is the gist of finding the volume of cones and pyramids. So now I'm gonna go through 5 examples and then you guys are good to go with that homework assignment. So let's just look at example number 1. First of all, I don't see anything that looks like a circle, so I'm gonna go ahead and say that this is a pyramid. All right, but then step 1, let's look at our steps. I need to determine what is the shape of the base. So I'm gonna look at the base of this pyramid. What is this shape? Well, I know this is a triangle, so I'm gonna go ahead and write down triangle. And I need to find the area of the base, which is big B. What is the area formula for a triangle? That's what we need to ask ourselves. So if you forget, look back up at your steps. It's 1/2 base height, so I'm gonna write that down. So I'm gonna copy my 1/2. What is the base of this triangle? Well, if we are just looking at this as a normal triangle, I can see it has a right angle, just telling me it's a right triangle. So that means that this 5 over here would be like our hypotenuse. We don't care about that. That's not the base or the height. The base is this 3 miles and the height is the 4 miles. If you switch around the base and the height, it does not matter. It just matters that you don't include the hypotenuse if you're looking at a right triangle. So the base, we're gonna say 3, and the height, we're gonna say 4. So I need to do 1/2 times 3 times 4. Well, I know 3 times 4 is 12, and half of that is 6. So what I just did was I found big B. That's what I found in this step, which is normally the hardest part. Step 2, I just need to identify the height. So I'm gonna look at my pyramid again. The height is labeled for me nice and neat. It's this 4 miles that's going up and down. So you want your height to be perfectly vertical and you want it to form a right angle with your base. That's how you know it's the height. So H equals 4. And then step 3, I just plug into my volume formula. So volume equals, and if we forget, we'll just look back up here, 1/3 big B times H. So that's 1/3. Big B was 6 and H was 4. Now I can plug this in my calculator and I am good to go. And you don't even have to plug it in your calculator if you want to do it in your head. I would start with the 6 times 4, which I know is 24. And then 24 times 1/3 is really just 24 divided by 3. So that would be 8. And my units would be miles, and I have to cube it because it's volume. So that is an example of a triangular pyramid. All right, on the next page, up, the area of a circle is pi r squared that we did, was a triangle base. We have a few more examples, 2 more cones, and then 2 more pyramids. So for number 2, I can tell that this has some type of circle in it. That circle is what tells me that I'm dealing with a cone because my base is circular. So I'm just gonna follow my steps. Step 1, identify my base. Well, I said it's a circle. And the area then, we can go back and forget. So you would scroll. So pi r squared. Then we have to identify the radius, which it looks like is 2. That's the distance that goes towards the middle point of my circle. So they were nice this time. They gave me the radius without me having to divide it into 2. So radius is 2, which means now I can find the area of my base. I'm just going to plug in 2 for r. So in your calculator, you can just type in pi parenthesis 2 squared, or you can square the 2 first and then multiply it by pi. Either way, you're going to get the same answer. So I'm going to go to the Desmos Scientific Calculator again, like we were doing in class. If you need to see anything in the calculator, let me know. So I'm going to type in pi parenthesis 2 close parenthesis and then square it. And I'm getting about 12.56. And you can round it differently. It's not going to be a big deal. You can also use 3.14 instead of the pi button. Either way, you're going to get about the same answer. So we get that the area of the base is 12.56. Now all I need to do is find the height. What is the height of my cone? Well, this cone looks like it's tilted to the side, but I know that the height is this guy right here. It's the thing that is perfectly perpendicular with my base, meaning it forms a right angle with the base. So if that helps you to remember what the height is, go ahead and write that down. Height forms a right angle with the base. So h is 7, and now I'm just going to plug into my formula. Volume equals 1/3 big B times h. And again, if you don't remember that formula yet because it's new, go back and look at the front page of the notes and you'll see it there. So 1/3, 12.56 times 7. I'm going to type this one in my calculator just because I can't do that easily in my head like I could the last one. So sometimes you'll have nice numbers, sometimes you won't. All right, so I am typing this in and I get 29.32. My units are miles again, and I have to cube it. Okay, so that's how we do a cone. So you can see that they're really the same exact steps. However, you just have a slightly different area of the base formula. Other than that, it's the exact same process for cones and for pyramids. Numbers 3 and 4 are just normal pyramids. However, their bases are different. So the first piece, now I'm looking at number 3, and I'm going to use a different color. Step 1, what is the shape of this base? Well, it looks like it is a rectangle, so I'm going to write that down. And now I need to find the area of it. So what is the area of a rectangle? Well, an area of a rectangle, all you have to do is take the base times the height, so b times h. And in this one, it's nice and easy to see. It doesn't matter which is the base and which is the height, but it looks like the dimensions of my rectangle are 2 and 5. So I'm going to say 2 times 5, which tells me the area of the base is 10. Step 2, I'm going to identify my height, which is pretty clear once again. So that's super nice for us. That height is 5. And then step 3, plug it in. So volume equals 1/3 big B times h. So I'm going to plug in 10 for B and 5 for h. All right, and then I'm going to take that and plug it in my calculator. So 1/3 times 10 times 5. And I am getting 16.67 or 16.6 repeating. So 16.67, and again, units this time, inches, but we cube it because we are multiplying 3 different numbers together. All right, and then number 4, very, very, very similar. Step 1, what is the shape of our base this time? Well, It's not a triangle because there's 4 sides. I'm tempted to say rectangle. However, it looks like they are actually the same length all around. So I'm going to say the shape of my base is a square. However, it doesn't matter. If I said rectangle, it would have been the same formula. So for squares, the area is either base times height, or you can just square one of the sides. We're just going to go with base times height because it's easier. It's kind of what we're used to. So the base and the height are both 11. So I'm going to do 11 times 11. And I get 121. So that is the area of my base. Again, we could have just said 11 squared because it is a square. You're allowed to do that. Same exact number. Won't change your answer. Step 2, identify your height. Again, the height is super nice and friendly in these types of problems. So it's really refreshing compared to when we were working with prisms and cylinders. It was a little more difficult to see the height on those. So the height is 12. And then I need to plug that into my volume formula. 1/3 big BH. So then I get 1/3 times 121 times 12. So I'm going to plug that in my calculator. 1/3 times 121 times 12. And I get 484. And my units will be centimeters cubed. So that one came out to a nice number. And finally, on number 5, the shape, I can see there's a circle in it somewhere, which tells me that I'm dealing with a cone. So step 1, let's identify what is the shape of the base. Well, if it's a cone, I'm dealing with a circle. So I have a circle. That's where the area formula is a little more complicated, like we looked at before. So the area of a circle is pi r squared. Again, if you forget that formula, either look back up at number 2, or you can look at the front page of the notes, and it has that formula on there for you. And you can also look back at your area notes from last week. So I have to identify the radius in order to keep going with the area of the base. When I look at my circle, I want to find what is the length from the center to the edge of the circle. So what is this length? Well, they give me this time the entire length. They give me the diameter. I want half of it. So I need to take 18 divided by 2, and that will give me my radius. So that means my radius is equal to 9. Now that I know that, I can plug it into my formula and get the area of that circle. So pi times 9 squared, I'm going to plug that in my calculator. So pi parenthesis 9, close parenthesis, and then square it. And I get 254.47. All right, so now I have the area of my base. Now I also need to find my height, which again, it's very, very nice and clear what the height is because it's right here with our right angle nice and shown. The height is 18. In step 3, just plug those things into our equation. So 1/3 big B times H. Then I get 1/3. Big B we found was 254.47 and H is 18. So I'm just going to plug that into my calculator and then I will be completely done. So 1/3 times 254.47 times 18, and I get approximately 1,526.82, and our units are miles cubed because it is a volume. And then I'm done. So you guys, this is our notes on cones and pyramids. Okay, so if you have any questions after watching this video, please let me know. I will post the PDF of these notes along with this video.